Good morning. I am going to work on today exercise number 3, and that's for the week 4 homework assignment. We're going to be working on the second triangle, so plotting the first triangle, and then with our MX, the time of maneuver or the distance for maneuvering, we're going to find what our new course is if we have to move. So I'm going to be working on the actual papers instead of the plotting sheets. I'm running a little low. And I'll be working through it. Also, I'm going to emphasize the format that the quiz is going to be in. So I'm going to emphasize first figuring out what our CPA and TCPA is, then figuring out the targets, true course, and speed, and then deciding what kind of situation it is. If we have to change course, I'll fill in whatever the problem says for MX and CPA, and then decide what my new course or what my new speed would be. And if they ask a couple other questions, I'll probably do those, but I really want to focus on this format for the quiz. So let's get started. Okay, so our first thing to do is plot what they give us. So we have our R of minute 0 at 2:10, and then M at 2:11 with our distances. So we'll plot those. Okay, so here I have plotted my 2:10 at 9 miles, so I'll label that R. Here I have 2:11 at 7 miles, so I'll label that M. And this was at 00 and 06. What I also didn't write in, but I will now, is my course and speed, my own ship. My own ship was 160. So own ship is 160 at 15 knots. Okay, so back to plotting my R and then plotting my M. Now I'm going to connect those two, and I get my relative motion line, my R to M, relative motion. So let's plot that. There is my relative motion line. So I could see that I am getting very close, or if nobody changes course and speed, we will get pretty close. However, they will pass behind us. I know that because this is my heading, and the relative motion line crosses behind my heading. But let's figure out what our CPA is. How I do CPA is find that right angle to my relative motion line to the center of the scope. So there is my CPA. I want to figure out the distance for CPA. My dividers won't go quite that small. About 0.5. 0.5 for our CPA. And now we want to figure out what our TCPA is. That's the time of CPA. How fast is this situation going to happen? So we know our relative motion, speed-wise, will happen 6 minutes at that distance. So 6 minutes later, it'll be there. 6 minutes. I'll make a little mark. 6 minutes. Oops. Okay, so we have 0, 6, 12, 18, 24, 30 as our timeline here. So our CPA is going to happen in between 24 and 30 minutes. So I might call it 27, 26, something like that. I'm going to do my TCPA. I'm going to call it 26 minutes. Again, it's give or take 3 minutes. So you got some wiggle room on that. Then they tell us our maneuver, our MX, is going to be at minute 12. So this is our MX. We want a new CPA of 2 nautical miles. So let's figure out first who has the right of way. So if I'm headed that direction, and we haven't figured out yet where this guy is headed, so we need to figure that out. I skipped a step there. So we need to figure out what they are doing so we can figure out if we need to change course or we have the right of way. So to figure that out, we need to transfer our heading flasher line back to R. R is going to be the back to R, so we can create E to R and E to M, which would be them. Okay, so let's get 160. That's the R heading. We'll go back to R. And I've created the R, but I don't quite know where E is yet, so I need to plot that. I do know my speed is 15 knots. So in 6 minutes, because this triangle is in 6 minutes, I would travel 1.5 nautical miles. So using my 60D street, I figured out 1.5, and so I get a distance of 1.5 nautical miles. And I plug that in. So here, I get my E. So now I have my triangle. E to R is my own ship. I am going 160 at 15 knots. R to M is relative motion. Now E to M is them, the other ship's course. So let's plot that. And then I'm also going to move it back to the center so I can see what that true course is. So the target is on a course of 079 at a speed, let's see what their distance is here. Oops. We'll call it 1.6, so that is 16 knots. So now I can go back to, this guy is headed in this direction. I am headed in this direction. Who has the right of way? Who is the stand-on and who is the give-way vessel? So I can see here this is a crossing situation, and he is to the starboard side. So he gets to stand on, maintain course and speed, and I need to give way. So I need to turn to starboard and let this guy pass ahead of me. And so I'm going to bend this relative motion line to cross ahead of me. So I need to bend it this way. So I go back to when am I going to maneuver, and that's going to be at minute 12. And how far do I want to maneuver? I want a CPA of 2 nautical miles. Luckily, our range ring is already at 2 nautical miles, so I don't need to create one. So I just need to create a line from minute 12 back to a tangent line on this 2-mile circle. So how close can I get? If I go over here, it's well past 2 miles. I want an exact CPA of 2 miles. So there, I create my new relative motion line. And with that line, I moved it. Okay, so this is my new relative motion line. And so I want to create a new relative motion line over here on my triangle, so I get my second triangle. So this is the old R to M, but I want to create the new R to M, the new relative motion line. So I still use my M, but I need to figure out where my new R will be. So here's my new relative motion line. Right, lined it up there. That's my relative motion line. And I'm going to start it, so I'm transferring it from MX back to M, so I can create my new relative motion line and figure out where my new R will be. So I go back to the M, and now I have my new relative motion line. So if I were to change course, meaning I keep the same speed, I'm going to put my same speed on here. That was 1.5 for 15 knots. So I have my E to R at 1.5. And then I'm going to turn my dividers clockwise because I'll be turning to starboard. So I'll turn clockwise because I'm turning to starboard. Now where that arc crosses my new relative motion line, this point is going to be my new R. So I call it R prime. So now I have a new triangle, E, R, and M. So not that part of the triangle. It's a little bit flatter there. So E to M, they maintain course and speed. I have my new relative motion line. And now I want to figure out what my new course is. So what is my E to R? That's my own ship. So what is my new course? parallel that to the center. So I have a new course. I am going to turn to the right from 160 to 212. So my new course is 212 degrees true. Degrees. You don't have to say degrees true. So that makes sense. It'll be turning to the right. Okay. Now what if I wanted to maintain my course, but I wanted to change my speed? So if I'm looking at E to R, and I need to create my R somewhere on this new relative motion line, and I maintain my course, where this new relative motion line crosses my course, that would be my R prime if I was to change speed. So I would slow down significantly, and let's see by how much. If I maintain my course, my new speed would be 0.6. So that would be 6 knots. Okay, now we're on exercise number 2. Again, our first step is to plot what they give us. So they give us our own course of 317. And they give us bearings of 010 at 9 miles and 010 at 7.5. Okay, so our first one was at 9 miles, bearing 010. So we're going to label that R at minute 0. The next one was at 7.5 miles, so we're going to label that M at minute 06. And now we can get our relative motion line. So we'll connect R to M. And our relative motion line goes directly through us, so our CPA is 0, or collision. Our time of CPA, we can get the distance from M to R. Okay, so we have 6, 12, 18, 24, 30, 36. So just shy of 36. So I'll call our TCPA minute 35. Pause. Okay, my next step is to figure out, since we have a 0 CPA here, who is the giveaway, who is the stand-on? What kind of rules of the road situation are we looking at? So I need to figure out what the other vessel's true course is. So I need to complete my triangle. And how I do that is I will put in my own ship's vector. My own ship was going 317 at 20 knots. So I'm going to move my 317 line back to R so I can create an E to R line. And then I'll get my distance there. So we'll get 317. We'll move it back to R. And then in 6 minutes, if I'm going 20 knots, I'm going to travel 2 nautical miles. So let's find 2 nautical miles. So now I have my E. So this is my first triangle. I have R to M, relative motion. E to R is own ship, my own ship. And I'm going 317 at 20 knots. So E to M is them. That's what the other vessel is doing. I'm going to parallel that down. And I have the target at a course of 266 degrees true and a speed of about 1.5, so that would be 15 knots. So that is my target speed. Now they told me I want to maneuver at mile 4 and a new CPA of 2 nautical miles. So I am here. The other vessel is headed in this direction. They're off my starboard bow, so they maintain course and speed, and I turn to the right. So my relative motion line, they are going to pass ahead of us, so towards that heading flasher. So let's draw in my new relative motion line. Our MX was at mile 4, so we have 2, 4. So here is my MX, and I'm going to bend it until it gets a 2-mile CPA crossing in front of me. So I'll put my MX and get a 2-mile CPA. So this is my new relative motion line, and I need to bring that back to my triangle so I can get my new triangle. This is my old relative motion line, and now I want to go from M to figure out where my new R will go. So let's get our new relative motion line paralleled back to M. So here is my new relative motion line. And now I need to figure out where my new R will be so I can get my new triangle or my second triangle. If I don't change speed, if I maintain my speed of 20 knots, there we go, I'm still at 20. I put my pointy side of my compass on E, and then I rotate my compass clockwise. because I am turning to the right. So there we go, we went clockwise. So wherever that distance crosses my new relative motion line, right here, that is going to be my new R, or R prime. So now I have a new triangle, E, R, and M. That's my second triangle. E to M remained the same because they maintain course and speed. R to M is my new relative motion line, which I know will give me a 2-mile CPA if I change course at exactly 4 miles away. And now I need to figure out what that course will be. So what is my course, my E to R, my own shift? Bring it back to the center. So my new course is going to be, I have 0, new course, 0, 0, 4. I have for my new course, and if I wanted to maintain my course but change my speed, that is going to be maintaining my course. So E to R remains the same direction, but if I change speed, the distance or the length of that E to R will change. So here the length of the R stayed the same for change of course. Change of speed, the distance of E to R changes. So we have where these two cross, that would be my R prime. So my new speed here would be 1.2, about 12 knots. If I wanted to change speed. So that is number 3. Okay, so number 3, we have our own course of 100 at a speed of 12 knots, and we have a bearing and a distance. So let's plot what they give us, and then we can see what it looks like. So we have 116 at 10 miles, and we're going to label that one R at minute 0. Then we had 115 at 8 miles, so we'll label that one M at minute 06. And now we want to figure out what our CPA is. So we'll connect these two. So we have a very close CPA, and they are also crossing in front of us. To figure out our CPA, I do the right angle, do it this way. So my CPA is very small. Let's see if I can even measure it. That won't even measure it. I'll use this. We got about 1 tick. So 1 tick. I would call that 0.3 nautical miles, maybe 0.2. It might be easier on the larger maneuvering boards to plot that. But next is our time of CPA. So we're just going to run down our relative motion line. Okay, so we have minute 0, 6, 12, 18, 24, and 30. So I'll give our TCPA of about, we can call it minute 29, 28, something like that. 28. That would be our TCPA. Now, because it's such a small CPA, I want to figure out who has the right-of-way, who stand on give way, what kind of situation are we looking at. So what is the vessel's true course and speed, the other vessel? So in order to do that, I need to plot the E, so I can get E to M, which is them. So I need to plot E to R, which is my own ship, and I know my own ship is 100 at 12 knots. So I need to plot that information. So we'll go back to 100. We already have that line there. And we'll parallel that back to R. And I need the distance traveled in 6 minutes at 12 knots, so I can plot that E. So that would be 1.2. So we do have a very small triangle here. Okay. So now I have my ER, my EM, and my relative motion, my RM. I need to plot what my E to M is. So that's my target's true course. Bring it back down to the center. And I can see that my target course was 322. And my target speed, really small here. Again, the smaller it is, the harder it is to be accurate because it's so much wiggle room. So we do the best we can here. I have 1 nautical mile. That makes a speed of 10 knots. So, that I can see, this guy is headed this direction, and I am headed this direction. So this would be a crossing situation. He is on my starboard side, so I need to give way to him. So I'm going to turn to starboard, and that relative motion line is going to pass in front of me. So they told us we had a maneuver at 12 minutes and a CPA of 2 nautical miles. So I already have that 12 there. So that is going to be my MX. And then I have a CPA of 2 nautical miles is what I want. So let's plot that. So this is my new relative motion line. So that's where I want him to pass. Now what is my speed or course change? So I'm going to parallel that new relative motion line back to M so I can get a new relative motion line on my triangle. Again, this little triangle here is very small, so we're going to do the best we can here. If I don't change my speed, if I maintain 12, I start on the E, and I'm going to rotate my R clockwise. Let me deal with this hand. There we go. It's very, very small here. But we have E to our new R. I can also, well, I'll plot that. What is E to R if I connect those two? Bring it down to the center. I would get a new course of, we'll call it 126 degrees. 125. I'm just erring on the side of caution. I'll go to 126. If I change my speed, I don't think I can go that small again. Just eyeballing it here. That's 0.5. I'm going to call it 0.3. So if I do new speed, I will call it, I need to go slow down to 3 knots if I change my speed. Again, this triangle is so small, their room for error is a lot there. So do the best you can, but we'll do another one and hopefully get a bigger triangle. All right. Okay, so we're on number 4. We have a ownships course of 120, speed of 23 knots. 120 is our bearings, and we got our distances. So let's plot what they tell us and then see what our triangle looks like. Our own course is 120. And our bearings are actually 120. Same, so they are dead ahead of us at 10 miles. So here's our 10 miles. And we can label that R at minute 0. And then at 8 miles. These are 8 miles. So we label that M at minute 0.6. So our relative motion line is going directly towards us. So we have a CPA of 0. I don't know why I said of 0 nautical miles. And then if I want to figure out my TCPA, I use my distance for 6 minutes, 12, 18, 24, 30. So my TCPA will be 30 minutes. That was 6, 12, 18, 24, 30. So now I want to figure out, I'm assuming this is, well, we'll see. What kind of situation are we looking at? So I need to plot where E goes. And I can see on here, this isn't going to be a triangle. It's going to be more of a line. So let's see where that line is. So I already have my course from R, but I need to plot where E will be. I know my speed, well, my speed here is 23 knots. So I'm going to find what distance I will go in 6 minutes, 2.3. So I have my 2.3 nautical miles from R, gives me an E of right here. So my ERM triangle here is not a triangle, it is a line. But if I look at each one individually, I can see what their information is. So R to M is relative motion. E to R is the own ship, so that is 23 knots in the direction of 120. Then E to M is them. What are they doing? So I can measure what E to M is. That's going to be 0.3. So I can say them, or target, is going from E towards M. So they are going the same direction as us. So their course is 120. Their speed is 3 knots. So that is their speed. They're going very slow. That E to M is a small vector. So if we maneuver at, well, let's look at the situation. They are going E to M, and I am going much faster. I am going to be overtaking. So which way do I need to go? According to the rules of the road, I can overtake on either side. They told us we wanted our CPA to be on our port side. So we will pass port to port, or not pass port to port. We're going to move our CPA to our port side. So that's going to be over here. So our maneuver is going to be at minute 12. So here's our MX. And then we want to move our CPA line in this direction. So let's plot that. That is our new relative motion line for when we are overtaking. So now I'm going to bring it back to the M so I can get my new relative motion line to my triangle. So let's do that. Bring it back. So now I have my new relative motion line going from M. And now if I maintain my speed, see, this was our 23 knots. E, I have my divider here on E, so I keep my pointy side on E, and then I will pointy side on E, and I will rotate my compass here from R. So let's try to get that. Trying to get it where it crosses there. So here, where this crosses, is my R prime. So that would be my new course. If I wanted to get a 2-mile CPA, I need to change course to the right so that my CPA will be on the port side. So what is that new course? Now we always measure from E to M. I know that M is very close, easy to get distracted by, but we want to measure E to M. Again, this is a small triangle, or E to R for our own course. So I'm going to parallel that down. And I have my own new course at 139 degrees. If I want to change speed, well, I can't overtake him if I slow down. So that wouldn't really work out. But this is an overtaking. Overtaking situation. So, yeah, if I want a 2 mile CPA, I need to come to the right. And this would also work if you come to the left the same amount. But you can bend your line the other way if you want to. So that is number 4. Okay, number 5. We have our own ship's course of 330 at a speed of 20 knots, and we have our bearings and ranges. So let's plot what we have. Okay, so our first one was 0 to 5 at 11 miles. We'll label that R. At 0, 0 minutes. Our second one was at 0 to 4 at 9 miles. We'll label that M at 0, 6. So we have an R and M. We can get our relative motion line. So this is our relative motion line. And in order to get the CPA, we go 90 degrees to that line. And there is our closest point of approach. So our CPA is at a distance of 0.8, 0.9. Let's call it 0.8 just in case. Okay, so we have a CPA of 0.8. they are going to be crossing in front of us. So here is my bow crossing point. This is the CPA point. So if I get a bearing, I can see that they're going to be crossing in front of us, but still at a pretty small CPA. So we're probably going to want to do something about that. Our next one is to figure out our time of CPA. So if I get my relative motion distance here to see my speed in 6 minutes, I could then plot out my 6-minute intervals. So here's minute 12, 18, 24, 30, 36. So we had 12, 18, 24, 30, 36. So in between 30 and 36, closer to 30, so I might call that TCPA minute 32. My next step is to figure out what situation this is. So I need to plot E to R, that's my own ship, so I can get E to M to see what they are doing, them. So I need to plot E to R first. So I'm going to parallel over my own course line here. My speed is 20 knots. So in 6 minutes, I will go 2 nautical miles. So here is my E. So now I want to figure out what E to M is. What is their course? Down here. Going to parallel that down. Didn't work out. Parallel it this way. They are on a course of 2, 6, 7. They are on a speed E to M. In 6 minutes, they are traveling 2.0 nautical miles. So they are traveling at 20 knots. Same as us, we are traveling at 330 at 20 knots. So if I need to figure out who has the right of way. So again, he is on our starboard bow with a very minimal CPA. So we need to change course to the right, and he will pass ahead of us, moving the CPA relative motion line in front of us. So we have a MX of 4 nautical miles. So here's 2, 4. So when this guy is 4 nautical miles away, that is when we are going to maneuver. And we want a CPA of 2 nautical miles. So we have a new relative motion line. We changed course at 4 nautical miles away, and we maintained a 2-mile CPA. So we need to bring back this relative motion line back to the triangle so we can create our second triangle. So again, this is my new relative motion line. And if I was to maintain my course, maintain my speed, excuse me, I keep it at 20 knots, and I rotate my compass to the starboard. I'm going to be changing course to starboard, and I get a new intersection of my new relative motion line and that distance to give me my R prime, or my new R. So I can measure E to R, bring it back to the center, and I get a new course of, we'll call it 006, 005, 006-ish. If I maintain course and just decide to slow down, what would my new speed be? So this vector stays the same, but my R would move to here for my speed change. .13, 1.3. So that would be slowing down to 13 knots. That would be my new course. All right, that's number 5. Okay, we have number 6. So we need to plot what they tell us and make our triangle and see what they give us. We have a heading of 0 to 5. At a speed, so I'm going to say own ship 0 to 5 at a speed of 15 knots. We have bearings 0, 0, 0 at 10 and 8. 10 and 8. So 0, 0, 0 at 10, that is going to be our R. At 8, that is going to be our M. I got this wrong. Let me put it on the other side. R at 0, 0, M at 0, 6. Okay, so let's plot R to M and get our relative motion line. Right through the center, we have a CPA of 0, collision, and our TCPA. How fast is this going to happen? So we actually have it spread out here. So that's 6, 12, 18, 24, and 30. So we had 12, 18, 24, 30. So our TCPA is 30 minutes. So our CPA is 0, and it's going to happen in 30 minutes. Let's see who has the right of way. So I want to plot the triangle to see what their true course and speed is. So in order to do that, I need to plot my own true course and speed, E to R, so I can figure out what E to M is. So we'll parallel over my own course at 15 knots, and so in 6 minutes, that's 1.5. So now we have an E. So E to R is my own course and speed. R to M is relative motion. E to M is them. What are they doing? So let's connect E to M. So target course was 137, and target speed is 10 knots. So let's see what we have. So we can see from this situation, it is a crossing situation, and I am on the starboard side. So I am the stand-on vessel. I maintain course and speed, and they cross behind me. They will go this way. So we do not need to change course and speed. We just need to monitor them to make sure they will change course and their relative motion line will bend this way. So if we don't see that bearing changing anytime soon to pass behind us, then we're going to need to do something. And again, we never turn to the left for a target that is to the left of us, so we would be turning to the right. They have us maneuvering, but we're the stand-on vessel, so if they don't maneuver, if they don't maneuver at minute 12, they don't maneuver, then we change course to the right to give them that space. So we'll try that. We're maneuvering at minute 12 with a CPA of 2 nautical miles. Again, technically, we're the stand-on vessel, but if we don't see them changing, we can maneuver. Okay, so this is my new relative motion line, again from minute 12 with a CPA of 2 nautical miles. I'm going to be turning to the right so that CPA is on my port side. You never want to turn to the left to a target that's on our left side. I transfer my relative motion line back up to the M in the triangle. Excuse me. So I can see where my new R will be. Okay, so my E to R line is still 15. Yep. So I am going to move my R to clockwise because I'm always going to turn to starboard. So I will move it here to clockwise. And I get a new R prime. So this is my new triangle. E to M didn't change. It should, but it didn't. R to M is following my new relative motion line. So E to R is my new course. Slow that down. So if I want to increase my CPA, I need to change course to we'll call it 055, 054, 055-ish. If I want to change speed, this one's a little bit tricky. I need my, so E to M would stay the same. I need to speed up. So where from my E to R does this cross my new relative motion line? So I kind of extend out. And this won't be a question for you guys, but just kind of playing out these two scenarios where those two lines cross, would be our speed change. So E to R would be a significant speed, which would probably be impossible. Yeah. Over 70 knots, so that would definitely be impossible. So we would have to change course. All right, so that was a little bit of a tricky one. Again, they were to, or we were to starboard, so we were supposed to maintain course and speed. But if they don't, we turn to the right. We always turn to the right. Okay. That's number 6. Number 7. We are on course 090, 20 knots, and we have a target that we need to mark. So let's plot this. We are on 090. With a target at 150. At 12 and then at 10. So 150 at 12 and at 10. So at minute 12, which is going to be that outer ring, that's going to be R at minute 0. This is going to be M at minute 06. So if I plot my relative motion line, all the way to the center. So I have a CPA of 0, or collision course, but I want to figure out what my T CPA is. So you can kind of see the trend here when we have it directly on the line, but let's see. 12, 18, 24, 30, 36. So our T CPA is 36 minutes. Now I want to figure out who has the right of way. What kind of situation is this? So we plot E. I will parallel down my own course. At 20 knots, so that's 2 nautical miles in 6 minutes. So I have an E right here. Okay, so I have E to R is my own course. R to M is relative motion. E to M is them. So let's plot what they are doing. So I have a target's course is 0 to 9 degrees, and my target speed is 20 knots. So again, let's see what kind of situation we have. This case, we have a crossing situation, and this is the vessel to starboard, meaning I need to give way, changing course to starboard, and he will pass in front of us, making our relative motion line go in this direction. So we have a MX at 4 miles and a CPA at 2 miles. So our MX is at 4 miles. And we want our CPA to be 2 miles. So there is our new relative motion line. I'm going to parallel that back to M over here so I can create my second triangle. So there I have my new relative motion line. And I need to figure out what my new course will be. So my speed is still set to 20 knots, 2 nautical miles. So I'm going to change course to the right and see where it crosses my new relative motion line. So here we have my R prime, my new R. So here I have E to M, they didn't change. I have the direction of my new relative motion line. And then E to R is going to be my own course, my own speed and course. Speed did not change. So I have my own new course. Real tight over here. So here's the other side of the triangle. My new course will be we're going to call that 153. So I'm going to change course to the right. Let him pass in front of me. If I want to slow down instead of changing speed, where E and my new relative motion line meet, this would be my second triangle, or that new triangle. So here would be my R prime. So I get the distance and convert it to speed. Or 11. Call it new speed. I think it was closer to 11, but we call it 10 just to be slow down a little bit more, give a bigger CPA. Or we call it 10.5, something like that. So that would be our new speed. So we had our two triangles. All right, so here's number 8. We are on a course of 270. And we have a target at 320 at 12 and then 10 nautical miles. At 12 and then 10 nautical miles. So at 12 nautical miles would be my R, minute 0, and at 10 nautical miles would be my M at minute 6. So our first step is to connect R to M and figure out what our relative motion is. Right through the center, we have a CPA of 0, or collision course, and our TCPA, this is just like last time, or just like number 7, 6, 12, 18, 24, 30, 36. Okay, so now I'm going to figure out who has the right of way. I need to plot my E. So I'm going to plot my own ship's course. $270. Bring it back up to R. And we have a distance traveled is our 2 nautical miles in 6 minutes. So now we have an E. Okay, so E to R is my own ship. So I'm going 270 at 20 knots. R to M is my relative motion. E to M is them. So what are they doing? Bring it back to the center. And I have a target's course is 201 and target speed I have target speed as 18. Yep. 18 knots. So let's see. In this situation, we have a crossing situation, and they are to starboard, so we need to give way. We will turn to starboard, and their relative motion line will pass in front of us. Okay. And that's going to happen at minute 4 with a CPA of 2, or excuse me, nautical mile 4 with the CPA of 2. So 4 nautical miles is our MX, and 2 CPA gives our new relative motion line. And now we are going to transfer that relative motion line back to M. This is my new relative motion line. So where does that R meet? We still have our 20 knots on here. So we start at our E to R, and we go clockwise, meaning turning to starboard. So here would be our R prime. E to R, bring it back to the center. Again, real crowded over here. We'll call our new course 325 if we maintain our 20 knots. If we want to maintain our course but change our speed, our R would happen to be there, making our speed, new speed, 0.9, so that would make it 9 knots would be our new speed. All right, let's do our last one. Okay, last one here. Number 9. We're on course 108. Let's plot what we know. Headed due south. And we have a target at 12 miles and 10 miles at 210. Okay, so at 12 miles, we'll label that R at minute 0, and at 10 miles, we'll label that M at minute 06. We'll plot our R to M to get our relative motion line and our CPA. We have a CPA of 0 or collision course. So you can see when we have the same exact bearings, our CPA is always 0. Our TCPA, this one is like the last two. Our 6 minutes happens every 2 miles. So 12, 18, 24, 30, 36. So our TCPA is 36 minutes. Now I want to plot see what kind of situation we're in. So I need to plot E. So here is my heading. We plot that from R. And I am going 20 knots, so that would be 2 nautical miles. Make sure this is, there we go. So we have our E plotted there. And now we have our triangle. Our E to R is our own. R to M is relative motion. E to M is them. What are they doing? So we'll measure E to M. bring it to the center so I can read. The target's course is 105, and the target speed is 1.0, so that would be 10 knots. Now that we have the E, we can see they are headed this direction, and we are headed this direction. So again, they are off our starboard bow, so we need to give way. They get to stand on. We turn to the right, and that makes their relative motion line come over in this direction. So we need to write that new relative motion line out. We have an MX of 4 nautical miles. And a CPA of 2. There's our new relative motion line. We're going to parallel it back to M. So our new relative motion line is over here. And if I maintain my 20 knots, still have 20 knots. Yeah. If I maintain my 20 knots, I rotate this in a clockwise motion, and I get my new R. So E to R gives us this new triangle. So let's see what our E to R is. Back to the center. Gives us a new course of 218. So we would come right to 218. Or a new speed. We wanted to change speed. Maintain our course, but slow down. That would make it this triangle with our new relative motion line. So let's see what our new speed would be. That's 0.9. So that would be 9 knots. So that would be our new speed if we maintained our course. So the more you practice, the better you'll get. Again, there's that wiggle room. So it doesn't have to be exactly my numbers. Most likely it will not be exactly my numbers. Everyone's a little bit different, but there is that wiggle room there. So keep on practicing and let me know if you have any questions.